So my name is Prafull Sharma, and CorrosionRADAR is a company based in the UK, Cambridge, and we make monitoring systems for asset integrity. Our community, which is corrosion engineers and RBI specialists, we help them make monitoring devices and connect to the RBI. So here we are talking about CUI, corrosion and insulation, which is one of the topics which we are passionate about to solve.
All right, thanks, Prafull. All right, Floyd, go ahead, take the stage. Can you give us a little insight on you and what you do with our industry, and maybe a little insight also on Antea?
Sure. Again, I'm Floyd Baker. I'm the Vice President, Antea Americas. Been in the asset integrity management business for my entire career, 40 years. About half of that career was on the end user side of the business with companies like Lyondell, like Phillips 66, Chevron Phillips, Koch Industries. And then the other half of that's been more around services and technology. And yeah, so happy to be here today. Looking forward to the conversation with Prafull.
Thanks so much. Thanks so much, Floyd. All right, so our agenda today, you are in the right place if you want to learn about technology, sensors for continuous monitoring, corrosion under insulation, so CUI. You want to learn how to leverage CUI data within risk-based inspection, RBI software to achieve predictive corrosion management, Antea's bread and butter. You want to achieve predictive analytics and corrosion prevention at your own plants and facilities. All right, Floyd, I'll let you take off with some terminology.
Yeah, so we'll just start and talk a little bit about RBI, because as this concept that Prafull and I are suggesting or presenting today comes to you, it's more or less going to wrap itself to the risk-based inspection methodologies and better understanding the risk, the of course consequence of failure, which there's not a whole lot we can do about the consequence other than shift volumes. But when it comes to the probability of failure, different story. We can actually do things that, perform inspections looking for specific damage mechanisms and either identify one, that they're there, and which is going to reduce risk because now you know and you can mitigate, or two, that they're not there, and which also improves risk. So this is a means of not only being predictive in terms of what might be there but also being more prescriptive in terms of determining the conditions that might cause an event to take place. And in this case, that event would be CUI.
Okay, thank you. So what is corrosion under insulation?
Prafull, you want to take that one?
Absolutely, that's a favorite topic I have. So CUI,
Yes.
I mean, there are many, like over 70 damage mechanisms, types of corrosion, and industry is battling with, and corrosion under insulation comes invariably among the top topics of the asset integrity. So it's basically a corrosion which happens on the outside surface of an asset, which is still hidden inside an insulation. Insulation can be anything like hot insulation, cold insulations, cold type, or any other type of insulations, but anything which is happening outside of an asset but hidden in the insulation falls in this category. There's nothing special on the damage mechanism. It's just that there's a limited understanding, of CUI. Why is it so fast? Why is it so accelerated? And where is it? So in the cost impact of CUI is huge in the industry, certainly billions and billions of dollars. And a lot of pipe failures, especially in Europe, where we sit, are reported due to CUI. So unsolved problems, and there's a huge opportunity to address this CUI problems and manage it better with technology, risk, and monitoring. Floyd.
Excellent. Next slide. So let's talk about the challenges that we're looking to solve here. We're trying to improve our ability to plan inspections as it relates to CUI. So basically, if you have sensors that can detect the conditions that promote CUI, then you can actually focus your areas, focus your inspections and your maintenance dollars where it creates the most value, where you see those conditions are higher risk for CUI to exist there. So it really helps you focus a whole lot of your maintenance dollars on where it's going to add the most value versus just stripping all insulation, or versus using other technologies that maybe not quite as accurate. What do you
And
think, Prafull?
absolutely, and as you said, that's on the inspection side of things. And when it comes to corrosion management and integrity management, can we be predictive? There's a whole lot of work going on in the industry about predictive tools, but they are based on assumptions as well. So can we be having a predictive corrosion management? And that's a huge opportunity for the industry. CUI is an example of that. We are seeing the initial applications of predictive corrosion management. So which means you're not detecting too late, you're actually proactively managing the risk. So corrosion management have a huge implications of technologies.
Yeah, for me, it's a lot more proactive means for CUI detection versus than the current concepts of actually going out and looking for a needle in a haystack. Even when you use technology, that's not always very accurate. So yeah, to me, it just makes a whole lot more sense. It's a lot more feasible, a lot more cost effective. It's just a matter of timing of implementation.
One of the things, Floyd, I like what your analogy is needle in the haystack, right? I mean, it's CUI is a special case. I mean, corrosion is a general case, but CUI can happen unpredictably at unknown locations. And the problem is the asset integrity inspectors and technicians and engineers, they're trying to be Sherlock Holmes. They're trying to find where that is, and in the process they have to overdo things like removing a whole lot of insulations, do a lot of NDT, right? And most of the times what feedback we hear is CUI is probably at a fraction of the location where they actually inspect. So the challenge and the opportunity is to proactively estimate or guesswork or even data-driven methodology to find where that likely location is going to be, rather than discovering using a Sherlock Holmes method. So you mentioned about needle in the haystack. Sherlock Holmes is my analogy.
Yes, exactly. Agreed. Slide. So we all know that risk-based inspection is more or less a methodology used to where one can actually calculate risk and better understand not only where they should spend their maintenance dollars, but also what they need to do, right? So you're gonna perform the RBI analysis based on a 580, 581 concepts, and you're gonna actually calculate the risk, and you're gonna calculate that risk looking for a specific damage mechanism. Now, then you can actually create your inspection test plan focused on that specific damage mechanism, whether it's a general thinning, cracking, or whatever the case may be. You can actually focus those maintenance dollars on the specific damage mechanisms that you're looking for. And this is how you mitigate that risk. You actually better understand, one, if it does exist, or two, that it doesn't. Either way it goes, it's an end to that means. Slide. So one of the ways that we like to look at it is through a digital twin. Now, for me, this just becomes so much easier because I'm a really visual person. Prafull, I like to I consume data or consume information so much better looking through visualizations. So the ability to actually look at that digital twin and better understand not only where the risk is, and not only that there is risk in my plant, but where it's at in my plant. And then be able to access all the information associated to that risk right through that digital twin. It's so much easier to consume that data visually than it is, or through visualizations versus tabulations. Tabulations, back in the day when I was younger, that was great. I could sift through Lotus or Excel spreadsheets all day long. I just dated myself, didn't I? Lotus isn't even a thing anymore. So I could sift through them all day long and glean a lot of information from that. But now I just don't have the attention span for it. I read a couple of years ago, right about the lockdown timeframe, COVID timeframe, where I believe it was Microsoft, or it could have been Google, was saying that humans have the attention span of a goldfish, and they say it's about 8 seconds long. So this is why the visualizations tend to capture their attention more so. And they consume the information that they're getting from that visualization so much easier. So accessing this kind of risk information through this digital twin and being able to access all the data associated to that specific asset or assets throughout its life cycle, to me, is most important. Being able to do this in just seconds is what's really key here. Being able to click on an asset or an asset's component or an asset subcomponent and actually be able drill down on that component or subcomponent or asset and do that in a matter of seconds. We did a case study, a survey with our customers a few years back, and asking some of the questions, where do they find the biggest return on investment through these visualizations, through the 3D models, through smart PNIDs, PFDs, plot plans, even Google Maps for that matter. Actually being able to access that information, and the most valuable return was on TTF, time to find, meaning the time to find the information you're looking for. And in a plant, we normalize the data across all these different size plants, numbers of plants, and so on, and normalize the data to 1,000 assets in a facility. And the time to find feature was $1.8 million per year. So a cost savings of $1.8 million a year in just being able to access information through the visualizations. I thought that was pretty profound. That even applies to anything to do with the CUI surveys. Maybe it's insulation types, maybe it's temperature ranges. All this information at your fingertips.
So Floyd, I just want to make an analogy here. So I would call this digital twin and 3D models and RBI and showing this is more of a, I would say it's getting into humanization of engineering. That's a direction we are going in. Visualization is a human way. I mean, we are not evolved to make tab tables and look at tables. Yes, we are trained to do that as engineers, but as humans, we are more visual. So the closer we do as a 3D models, even risk, the closer we are to humanization. So that's the direction I would say everybody's going. And I think you, Antea, have done a great job in making it boring 2D tables to a 3D visualizations as well. What do you think?
I agree. As a matter of fact, we were the first to introduce 3D models in an asset integrity management platform in 1996. Computers were still relatively new back then, certainly the visualization. So again, seeing that, being a forward-thinking company and seeing this evolution take place, the 3D models was only part of it. 3D models and also 3D point cloud. So digital twinning. But the key here, in my opinion, isn't just the data we capture in the moment of an inspection or a test or a CUI survey, anything like that. It's really about having the edge environment speak back to us, the asset itself speak back to us. This is what really creates the digital twin, because it's actually talking to us now. It's telling us how it feels, what its temperature is, what its pressure is, what flow rates are. Now we get those visualizations begin to speak back to us. And that, to me, is where we really close the loop and bridge that gap between information technology and operational technology.
So if I'm a user of this, say time to find is the metric, but then I will be able to explain this just to my management and my fellow engineers in a much easier way because it's a visual tool, right? So time to explain is another one which I like, personally. Time to explain, time to communicate. Otherwise, I have to communicate through reports, which is again is a boring way.
Yep, agreed. So types of corrosion data captured. We know we always capture our NDT data, so kind of humans as a sensor, if you will. Technicians, inspectors going out in the field and gathering, whether it be ultrasonic thickness data, phased array, whatever, radiography, whatever kind of data they're capturing, and bringing it into a platform so that you can actually analyze it and manage it. The other parts of that is ensuring that your corrosion probes and coupons programs are all connected also, because this is all corrosion and damage data that you want to be able to monitor in a platform. Lab analysis. I know this sounds a little bit off task for asset integrity, but the process affects metallurgy, right? Process not only the constituents that make it up, but also the pressures and temperatures it runs at. Everything can change the pressure envelope in some way, shape, or form at some level. So also remote sensors. We know we can capture data from remote sensors, either from remote sensors directly or from PI data from data historians, DCS, PLC. All this sensor data is really valuable. Now, here's where it really gets interesting, where you actually connect to this to the CorrosionRADAR platform and actually be able to access that sensor data to better understand and track and monitor the conditions that promote corrosion under insulation right there in your digital twin. This to me is really interesting.
Absolutely, Floyd. And I would make analogies here again. RBI. I think what the parameters which you are showing there are two types mainly. One is the leading indicator, and the other is the lagging indicator parameters. Lagging indicator is too late, but still useful to capture. It's hard evidence getting into RBI. But leading indicators are also important. So one of the aspects which I will talk about is, example in CUI, we have in API 581, we have like conditions like marine, or is it severe dry climate, is a kind of leading indicator. But what we also do through the remote sensors is an additional parameter like moisture sensors, moisture in the insulation. So that's an example of a leading indicator which does not necessarily lead to corrosion right away, but much in advance it adds to the risk tables. So leading indicator, lagging indicator is a good way to look at these as well. And I like leading indicators because that is much ahead, or much in advance. It can predict the risk.
Yeah, it's much easier to predict and plan in order to mitigate, instead of the lagging indicators, of course, where you've already got a problem and you're having to deal with that.
Yeah.
Slide.
All right, so now we talked about CUI, we talked about RBI, we also talked about digital twin and the opportunities lying ahead, humanization, Sherlock Holmes. How do we do this? So how do we achieve continuous CUI monitoring? Now we have seen CUI to be inspection oriented, lagging indicators based inspection oriented, visual inspections. But now is a technology which I'm talking about, which monitors the parameters, few parameters, which are leading indicator parameter for CUI. So jump into technology. So next slide, please. So in the CUI space, the core problem is when and where is risk going to happen much in advance. So suppose CUI has not yet happened. Probably these are newish pipelines or older pipelines, not even pipelines, some assets, pressure vessels. The core question is where it's going to happen. So because of that, CorrosionRADAR have invented a technology which is a long-range sensor technology. So it gets installed. What you see on the screen is the orange colors are basically wire type sensors which are about 100 meters long at a time, connects to a data logger with a blue box here, and transmits the data wirelessly to softwares. It can be any software, data visualizations, and RBI softwares, Antea. So in this case, the sensors are interesting in the sense the sensors are covering a wider range, long range, and there are two types of sensors, moisture sensor and corrosion sensors. And moisture sensor is a leading indicator of finding out where the dry environment is, where the wet environment is. So that earlier we talked about needle in the haystack. So this is finding the needle through sensors without Sherlock Holmes there. So that's a moisture sensor, and the corrosion sensor is an augmentation of that because moisture does not necessarily lead to corrosion. So corrosion sensor is the longest coupon in the world, which we have here like a wire. And it locates where the corrosivity is. Is the corrosivity medium, high, or low, or very high? That level. So this is about when and where CUI is likely to happen. And then all this data is combined and analyzed and put it into risk tables and connects to the RBI matrices. So that's the language. Risk is the language, but the source of the data is moisture and corrosivity sensors. This device is widely available, ATEX rated or explosion proof rated, and I'll talk about some of the case studies. Next slide, please.
Next slide.
So here's a video of example of a digital twin aspects of how this affects. Obviously, the sensors can be used even without digital twins, but the enhancement is with digital twins. So this is an example of a tank. The sensors are both corrosion and moisture sensors are wrapped around, and they're sampling a wider area rather than a spot, and the data gets transmitted. And here you see that key locations are identified where the risk, in this case, is medium. So it's really localizing specific spots. In this case, you need not create a scaffolding. You can just do rope access, save the cost, and really inspect where to be done. Now, this is another example where it's a high tower, say 25, 30, 40 meters high, and normally scaffolding are needed to inspect the whole lot. But if we can pinpoint using sensors where the greens are and where the yellows are or reds are, then we can be targeted in our inspections. We can be targeted in our scaffolding. In fact, we need not do scaffolding. We can do rope access. And that's on the scoping side, but also time-wise, if everything is green, then skip the inspection, or defer the inspection if there's a need. So it helps in the decision-making aspects of that. I think the video is stopped. If you can see if we can play it again.
Stopped.
All right, so it's working. Further on, there are, for example, where the immediate threats are, nozzles, protrusions, those are the spots. Now the sensors can be routed through those. And if we know in advance that, okay, those are the risky locations, others are green, others are yellow, those can be prioritized as on the whole asset. So save cost savings there and safety as well. Complex geometries like these, very difficult to categorize them as to, hey, is it a pressure vessel? Is it a pipelines? What kind of methodology we have to apply? So we apply sensors in a complex fashion. It is designed that way, and once the sensor data is transmitted, it really tells when and where it's likely risk is high. So in this case, top and bottom. So, but it can be anywhere as well. Another example is a heat exchanger or a pressure vessel. So in this case, the nozzles are a priority inspection locations in the risk tables. But if the sensors are routed and it tells us that no, some of the locations are fine, but some of the locations are actually higher risk, this is about higher resolution of risk. Normally, this whole tank or vessel will be one risk, but now we are actually giving a high definition of risk using sensors here. So you see only two locations were identified risk, so other locations can be skipped with the inspections. So yeah, and next slide. So that's the power of digital twin and monitoring technologies. There are these monitoring CUI monitoring technique have been deployed globally in different applications. So you see on the screen what kind of applications. So there are dryers, deethanizers, which are very prone to CUI, the columns and pipelines, critical pipelines, green fields, brown fields, as well as the storage tanks you see there. One of the key good applications are cold assets and cryogenic assets, which cannot be inspected in live conditions. So we need to understand the risk of those in live conditions, because you cannot inspect them. They form ice if you open up the insulation. So that's one of the primary application as well. So yeah, various applications of different kinds globally. Floyd, do you have any comment on the applications?
Yeah, no, I agree. You can actually spread it across many different types of processes. It's just a matter of when you apply it. And again, you mentioned cryo services, and also there's something that happens. Implementation would be during an outage or during new construction. Really, greenfield is the best place to install. But even when you're doing a CUI survey and you're stripping a lot of insulation anyway, the opportunity is there to go ahead and install the sensors. Yeah, that's my suggestion.
One of the other applications is the T&I, the turnarounds planning. So you talked about cryo services or cold duty services, or even intermittent thermal cycles operations. Some of them can only be inspected during a turnaround because it needs an equipment shutdown.
Yeah.
But if you know proactively that this equipment is fine, there's no threat, there's no evidence of water ingress or corrosivity conditions inside, then it can be kept outside of the turnarounds. So turnaround can be optimized. The other way of looking at it is many times in the turnarounds we find CUI unpredictably, and then the turnaround becomes more extended. Now this is about managing the risk of turnaround extension as well, to know proactively when and where to inspect.
Much better to know in advance than it is to get in the middle of a turnaround and then find you've got not only you got long lead materials in some cases, but then you got overtime. You've got everything is at premium at that point, and you're extending your downtime, which means you've got lost opportunity, meaning the opportunity to be up and running and making product. Yeah, never a good situation. Always better to know in advance, and with tools like this to be able to know in advance and plan for it before you oil out.
Good case study here, which is among my favorites as well. The top, this is because this is a very high production column, and I was personally involved in talking to the end user here, they came with a lot of pain that this asset is 40 years old, and this is in Netherlands, and they had to do life extension of that. So they were managing risk, but this is beyond risk. They know the risk. This is high consequence and high risk. Uh, and they have to do inspection every few years just because it's a life extension program. They have to do every 5 years or 6 years. They know there's a condition of CUI. Now, what they came up with that, hey, we know we have to inspect this every 6 years, but it creates a scaffolding, and we have to inspect key locations like rings of support rings, which are prone to CUI, and nozzles. But can we be smarter? Can we inspect it only when needed? So that's where this monitoring came in, and the sensors which you see on the screen, which is helical fashion, it was installed in key locations. And this has been a few years, and they have actually detected that CUI conditions are not there in most of this asset. There's insulation is perfect, but at a certain location, they found that water ingress is happening and CUI conditions are getting developed. So that location on top is being publicized. This company and end users have publicized that we have detected using technology, and now we are doing rope access based inspection only on that particular location. So we are managing the risk in a much better way. So in that sense, if you see the RBI table there, they're saying that we reduce the risk because now we know much better where things are going to be. So officially reduce the risk, extend the inspection intervals, and save the money. So a very good use case of a production column.
Yeah, I agree. That's a really good example right there. That's that's a perfect example, a case study of value add for utilizing a more proactive, predictive means in the sensors and the sensor data. Integrate your CUI monitoring with RBI. So this is basically what is being more predictive about your inspection testing, specifically CUI inspections.
Analogy of human as a sensor, because we have the best sensor in the world, eyes, ears, and the brain, estimations. But there are limitations. We can't see under the insulation, for example. That's where we have to augment with all these sensor technologies, X-rays, for example, pulse eddy currents, and monitoring technologies like sensors. Where our human limits are, can we augment with technology and use a better decision making?